Okay, so last week we were covering just sequences. If you go back to our very first day of notes last week when we came back from spring break, we talked about a sequence is an ordered list of numbers in a particular arrangement that follows some kind of pattern. What we're going to be talking about this week are series. And the series is a sum of terms in the sequence. So instead of listing the terms like a sequence, I'll pick, remember one of the patterns we saw last week were the perfect squares? So I'll do perfect square pattern. A sequence with perfect squares would look like 1, 4, 9, 16, ... if it was an infinite sequence, right? A series is the sum of those terms. 1 plus 4 plus 9 plus 16 plus ... So you see the difference between a sequence and a series? Commas, a list of terms, plus signs, the sum of terms. Okay. Now, the way I have written my series here on the board and my sequence, these are both infinite. Okay. This is an infinite sequence, and this is an infinite series as I have it written, right? The ... implies it doesn't stop. So if I asked you, if I kept going, plus 25, plus 36, plus 49, and I just leave it open, could you ever calculate the sum of that infinite series? No, it's just going to keep getting bigger and bigger and bigger as we add larger and larger of the perfect squares, right? So most of the time, if you have an infinite series, a sum of terms in the sequence, there will be no sum. There is one exception that we'll get to on Wednesday. So we'll be dealing with finite series where we often put in a last term. So now I'm going to introduce something called summation notation. And summation notation is also sometimes referred to as sigma notation because that big Greek letter that looks like sort of a fancy E or something, that is sigma. You've always wondered. Now you know, sigma. I'll let you jot that stuff down, then we'll talk about what all those parts are. Okay, so, maybe you've seen sigma hanging out in different locations. If you have ever done much in Excel, I think it shows up in Excel, like Microsoft Excel. Because what sigma generally means for us is add up all the things. So sigma means sum, like add everything up. And that's why we can use the phrase summation notation, or some people call it sigma notation, which implies summation. Now, usually you see them on top and on bottom of sigma, but sometimes they're like right next to the the brackets of the sigma, so they'll come here, and 2i will be a little bit later. But these are your lower and upper bounds. So on the bottom is going to be your lower bound. On the top is going to be your upper bound. So it tells you like how many things you want to add. I want to add from I equals 1 to 4. And when we're talking about sequences and series, that's saying the first term plus the second term plus the third term plus the fourth term, and then I'm done. Okay, so it will tell you how many terms you should be adding here. Okay. Now, I is the index of summation notation. And one thing to note about the index is it can be any letter. So it's often used or written first as I because it's an index, so we use I for index. But like when you're doing sequences and series, a lot of times we would use N because we talk about the N term. So if you want to change that to N equals 1, that's fine. If you prefer to use X's, you could do X equals 1. It can be any letter that we want for the index. Okay. And then there's always, so you've got the summation notation, you've got your lower bound and your upper bound, so you know how many things you actually want to add, and then you want to know what to add. So the thing that comes behind the summation notation is your rule. It's like your A sub n. How will you get the first term, second term, third term, fourth term? You'll do 2 to the I. Now, whatever index you've chosen, whatever letter, if you want to use I, N, X, it should match in the rule. So then I used I here. I'm usually pretty bad when I'm writing stuff. I usually get them flip-flop, but it should match. Okay, so if you change this to N, then this will be 2 to the N. Because it's saying you're subbing that number in for N or I or whatever that may be. Now, I also always do this in my math classes when my teacher tells me how to say something. I always write down in the margins how to say that, because I have a hard time with that, making sense of the symbols. So when you read that summation notation, it says the sum from I equals 1 to 4 of 2 to the I. So you read it as the sum of your lower bound, I equals 1, to your upper bound, 4, of the rule that comes behind. And that's how you would say that out loud to someone. If we actually wanted to do this, to find the sum, we would have to do 2 to the first plus 2 squared plus 2 cubed plus 2 to the fourth. Right? That's what it says, the sum of I equals 1 to 4 of 2 to the I. So we're replacing I with all of those values from 1 to 4. And then that's 2 plus 4 plus 8 plus 16. So what am I at? 24, 28, 30? So that's the sum of the series. These two pieces right here would be your series. They're the sum of the terms. This right here is the sum of the series. And this stuff over here is summation notation. So there's really like 3 things to think about. Anybody got any questions for me? Okay, let's look at some examples. Find the sum of the series. Oh, that's boring. We already did that one. My apologies. Yes, Mason.
30.
Oh, thank you. 30. Yes, you're right. I agree. Great job. Star student. Okay. Here's another type question. Write the series in summation notation.
Positive, minus. You already throwing
So like on top, like the upper bound, does it always have to be 4?
No.
Okay.
That's fun.
Let me ask you this. What's the upper bound for this one? Limitless. What would you put up there for limitless?
Infinity.
Infinity.
Oh my gosh. Look at me. I actually did something.
I love drawing.
I mean, did you?
Hey, excuse me. I figured it out. This thing you put above it.
Because I don't have an ending, right? So go to infinity. And what else do you have to do to get it in summation notation? You got to figure out what should be in the place of what 2 to the I was for the last one. Yeah, 2 to the I was the rule. So we need to think about patterns. Last week, can you write a rule? So talk with your pods. See if you can come up with a rule. Today, just so you know, I'm not calling it arithmetic series. That's tomorrow. I'm not calling it geometric series. That's on Wednesday. So this could be any kind of series. You might have to think outside the box, right? Okay, write that rule. See what you can come up with.
So
It doesn't have to be, but we're going to assume, because we just have that series listed, that 6 is the first.
6 to negative 5.
But like I could, like where I said I equals 1 to 4 of 2 to the I could have said I equals 3 to 7 of 2 to the I.
Then you have like 2 plus 2 to the 4 and 2 to 5.
I was subtracting 15.
So it doesn't have to be 1, but if you're not told her like what that is in the series, you're going to do that.
And then
We're
going to because 6 minus 1.
What is that rule for that sequence?
But it has to be like a negative 1.
What are we going to do about that alternating sign, you guys? There should be a negative somewhere. How did we alternate signs back on day 1 last week? Negative 1 to some power. Okay, so I'm going to do a negative 1. If I raise it to the n, then negative 1 to the first will come out to be what kind of number? A negative, when it's actually a positive. So how can we adjust that? Do a plus 1. So now when I put in 1 for n, oopsie, I did that thing again. My index should match. Okay, do an I. Should be I plus 1. But if you want, you can change this to n. So now if I did 1, 1 plus 1 is 2, negative 1 squared is positive. And then when I do the second term, 2 plus 1 is 3, negative 1 cubed is negative, and then positive, and then negative. So it's going to work out to give us our things. Now we can just concentrate, and I'm going to think like a sequence. Now that we've fixed the sign issue, I can now just think about these numbers, right? I got the alternating sign. Has anybody figured out a pattern? Goes up by odd numbers. Plus 3, plus 5, plus 7. Oh man, we talked about this last week. What set of numbers goes up by odd numbers? Perfect squares. But the perfect squares I think I used that on my sequence versus series slide. That's 1, 4, 9, 16, 25. can you add 5 to your perfect square? So the perfect square is I squared plus 5. Okay, let's check that out. Let's try one. So a sub 1 would be -1 to the 1 plus 1 times 1 squared plus 5. That'd be positive, and then 6. And let's try like the fourth term, see if it works out there. -1 to the 4 plus 1 is 4 squared plus 5. That's going to be a negative, and then 16 plus 5 is 21. Did we find the right rule? Yeah. So it checks. What's that? The -1 to the I plus 1 is also part of the rule.
Okay.
Because that part is the part that changes the signs. Over here, I forgot about the changing of the signs, so that I could focus on the fact that they were going up by odd numbers.
So like,
Now,
if it wasn't negative, would you have to still have like the 1 to the I plus 1?
if they weren't alternating signs, if they were just plus, plus, plus,
You just have the I
I
squared
would just have I squared
Okay.
plus 5, yeah. Now, I consider that one to be like more challenging than what I'm probably going to put on your test on Friday, right? So it's good for us to do some that like make us really think so we can do some of the easier ones. Okay. Okay, an employee at a construction company earns $33,000 for their first year of employment. Employees at the company receive raises of $2,400 each year. What's the employee's total compensation after working with the company for 5 years? So this was a lead-in from your quiz on Friday, if you'll remember. Okay, it's kind of like working you up to what we're doing this week, which is series. Okay, so you could do it without all of my information. Let's first write this in summation notation. So you and your pods. What's your summation notation going to look like? Go ahead and have a go at that. And then if you want to work on the total compensation, you can.
Oh, so you can do whatever 33 minus 33. The issue is because that's the how much they get their first year plus their
So I guess so. And then it would be infinite would be
33.
It might.
No, because you
do like 200 and
No,
Okay, I'm going to interrupt. Before we get get down to the summation notation, I'm gonna say I saw a lot of people on their quiz last week. They were able to actually like start up the series work without knowing about series as a sum of terms in a sequence, right? How much money do you make your first year? 33,000. And then how much money do you make your second year? 35,400. And how much money do you make your third year? 37,800. And how much money do you make your fourth year? 40,200. And how much money do you make your fifth year? 42,600. I didn't even really need a rule or anything, right? I could just come up with the list of terms in the sequence, which a lot of people did on their quiz. Yeah, that works, right? So this is what we would call the series. It's the sum of those terms. If you're thinking about it like that, then what's your lower bound? I equals,
2,000.
what term is this? The first term. So I equals 1. And what term is this? The fifth term. So I equals 1 to 5 of, and you gotta come up with a rule. Any ideas out there for a rule? Aiden?
33,000 plus 2,400 times I minus 1.
I'm gonna write that down. 33,000 times, sorry, plus?
Plus 2,400 I minus 1.
Oh, 2,400 times n minus, or I minus 1. Can you explain why you chose to do it that way?
I just know it's right.
Why?
Because I checked it out.
Oh, okay. Did you come up with it like originally as I minus 1?
No, it was originally I, and I realized, get a raise the first year.
Okay, yeah. I got a lot of this on the quiz. A lot of people went ahead and they wrote their rule immediately as like 33,000 plus 2,400 I. And then they did the first 5 years like that. But then your first year, you're making the starting salary plus the raise, which they're not going to give you a raise your first year. You got to work 1 year, right? So there's a couple of adjustments you can make. You can subtract 1 from I. And this, if you look, is the arithmetic formula from the book. Okay. Or you can also tweak 33,000. Did any groups do that? Subtract your raise from 33,000. So what was that? Minus 2,400. So 30,600 plus 2,400 I. That's like if we use Aiden's formula and we distribute the 2,400 and then we combine the like terms. This is like my A sub 0 in an arithmetic sequence. So either one of those is fine. I'll use Aiden's. 33,000 plus 24,000 times I minus 1. And, okay, we got summation notation. We got low bound, high bound rule. We got the list of the series. All the terms added together. Now, what's the sum? Somebody's got to add them all up. Even? Does anybody second that? My other people adding?
Yes. Yeah.
So this right here is the sum of the series. Notice I'm labeling all three parts because what your answer looks like depends on what the directions are asking you to do, right? If it says write it in summation notation, you just need to write it with the sigma, low bound, high bound rule. If it says write out the series, I should see all 5 terms that you're adding together. If it says find the sum of the series, we should be adding those up. Now, lead in for tomorrow. This one is arithmetic, because my raise is $2,400 every year, right? Plus 2,400, plus 2,400, plus 2,400. So we have that 2,400I. Oh, I put too many zeros on that, didn't I? I knew something was not right when I was writing that. Squished in there. That would be awesome if I got a raise of 24,000. But I'm not going to. Okay, so that's arithmetic. So you have a common difference between your salaries. I keep adding the same amount every year. Tomorrow, if the series is an arithmetic series, meaning the terms in the series differ by the same amount every time, there's a shortcut. And by shortcut, I mean I don't have to find all 5 terms and add them up. Okay, I'll have a shortcut. It's really a formula, but we'll kind of tell a story about a mathematician, how he got one on his, 3rd grade teacher or something like that, okay, and figured out the sum of the arithmetic series. So we'll look at that tomorrow. That's the lead-in for tomorrow. Today, though, if I ask you to do a sum of a series, you just gotta find all the terms and add them up. And how do you find all the terms? You plug them into the rule over here. Okay, so here's your homework assignment. We got about 13 minutes. Everybody should get going.